Alright, this is the second video in the three-part learnings videos for chapter 6, lesson 4 of transformations of trigonometric functions. And in this video, I'm going to be going over how to find the equation from a graph, from a sinusoidal graph. Now, the only thing that I want to cover before getting into that is recognizing the similarities between sine x and cos x graphs. So for the most part, sine x and cos x graphs are exactly the same. You can see that they have the same peaks. They both peak at they both have a max value of 1. They have a minimum value of -1. They both have a period of 2 pi because that's how long one cycle takes. Same domain, same range. For the most part, they're exactly the same. The only difference between the two graphs, or the two functions, I should say, is if you take a look at this. So if we have the blue representing cos and the red representing sine, right? You can see that the blue peak here isn't too far off from the red sine peak right next to it. And if you can kind of visualize it in your head, if we shift the sine graph a little bit to the left, you'll notice that they actually perfectly line up. And the reason I'm mentioning this is because when writing an equation for a graph, if you're not told by someone to either use sine or cosine, if you have to use one of the two, both will work, but the equations will look different just because one of them does have a horizontal shift, and that would be the sine x graph. So here in red, if I did sine of x, now if I did plus pi over 2, and if you remember from the last video, if I do x plus pi over 2, then that means that the entire graph will shift to the left by pi over 2. You'll notice that they are now the exact same graph. They both line up together. And again, this is important because when making an equation for a graph, of a trigonometric graph, you can either use sine x or cos x. It's just you're going to have a different equation based on what you use, and sometimes it's easier to choose one than the other. For example, if you notice that the graph starts at a high or starts at a low when x is 0, then you're more inclined to use cos x because cos x starts at the max or the min, depending if it has a reflection over the x-axis. If it doesn't, maybe it starts in the middle, you could use sine x or maybe cos x with a phase shift, let's say. So it honestly depends on what's easiest and what you're trying to accomplish. All right, so let's take this graph that I made in Desmos as an example, and let's try to find the equation for this graph. Now, while it does look complicated, this actually isn't that hard of a process, and that's because whether you use sine or cos to find the equation of the graph, a few things are always going to be the same no matter what you use. So I'm going to put constants here. And those things are your amplitude, your axis of symmetry, or let's put it in brackets, let's put C value, A value, and then K value. These things are always going to stay the same no matter what, even if you use sine or cos. Now, the things that could change are your phase shift. You might also have a reflection over the x-axis. That could also be changed. And that's mainly it. So it's those two things that are, for the most part, the hardest thing to find. But the constants are what I feel like should probably be dealt with first because those are going to be the easiest. So let's think of an equation for this graph. So first of all, we always start with y equals. And now let's find some of our values. So first of all, let's find our first constant, which is the amplitude. So amplitude, if you remember the formula for amplitude, it is going to be the y max minus the y min divided by 2. And our max, you can see this goes up by 1, so our max is going to be 3. And our minimum is -1. So that's going to be minus -1 divided by 2, which is equal to 3 plus 1, which is 4. 4 over 2 is 2. So right away, we know that our amplitude is 2. So our amplitude is 2. So y is equal 2. That's our first thing. Next thing we can find is our axis of symmetry. So our axis of symmetry is going to be our y max plus the y min over 2, which is going to be equal to 3 plus -1 over 2, which is equal to 2 over 2, which is equal to 1. So now we know that our axis of symmetry, also known as our C value, is going to be +1 at the end. Next is our K value. So I'll do K value in a different color. Let's do red. So our K value. So if you remember how to find our K value, we have our formula K is equal to 2 pi over P. P is period. And the way to find the period is basically just take a look at the graph and find how much time, I guess you could say, or how many radians, or how many degrees, or how many, whatever unit the x is, does it take to complete one full cycle of the graph. So you can measure this by looking at the peaks of the graphs. So you can look at it by, let's say we have the highest peak over here. This is one peak, and the next highest peak would be right here. So because this is 2 pi, that means this would be 1 pi here, and then 4 and 6 pi, this would be 5 pi. Now because the graph is going from pi to 5 pi, that's going to be one complete cycle. So you can do 5 pi, we'll just do in this corner, 5 pi minus a pi is equal to 4 pi, which is equal to our period. And now that we have that, we're able to find our K value. So K is equal to 2 pi over 4 pi, because now we know that our P is 4 pi. Our K is equal to 0.5. So now we have that. So it's going to be 0.5. Actually, I'm going to write these at the end when we collect all of our information, just because it might get a little unstable. All right, so now it gets a little bit more complicated because now we have to find if we have any variables. So you can either, again, now you can either choose to use a cos or a sine. And just by looking at the limited information that we have here, because we can't really see behind the function too much, I'm going to use cos. And this is because I know that cos always starts at 1 as a base. The y-intercept, it starts at the max. If this is our cos graph, which looks like this, it starts up here, right? And because it starts up there, and if we take a look at our own graph, we can see that the start is over here. Or sorry, the start is down here. But if we just take this point up here and shift it from where the cos would normally start, so if cos would normally start up here, and we shift that to there, then that would mean we have our proper working equation. And because we're shifting the cos, and because it's starting at the maximum and not the minimum, there is no reflection over x-axis. So because there is not starting at the minimum, there is no reflection over x-axis. If it's starting at the maximum, then there will not be the reflection. So let's make our equation. So let's have y equals, so again, no reflection over x-axis. Just change that to pink. So we have no reflection over x-axis. So then we move on to the next thing, which would be the amplitude. And we found that our amplitude is 2. So we have y equals 2. And we also said that we're going to be using cosine. So we have y equals 2 cos. Then you open your brackets. Now we have our k value, which is 0.5. So 2 cos of 0.5. So I'll rewrite that better, 0.5. And now we have to determine the phase shift, because we already said that the graph does move to the right, which means we have to find the phase shift. And from here to here, it's pi. That distance is pi. And because it's shifting to the right pi, then that means we are going to have x minus pi in brackets. Again, minus because it's shifting to the right from where it would normally start. So if we normally had a cos graph, it would go something, let's say, just as an example, a normal cos graph would go like this. But because this max is being shifted to the right by a pi, we do x minus pi. So now we have x minus pi, and then our last piece is our our axis of symmetry, our c value, which is 1. And then we have plus 1. And if you graph this in Desmos or just on paper or by hand, then you should come to the same graph up here. All right, so for our second graph, we're going to move a little bit faster. So first of all, we're going to find our amplitude. So let's just put it up here at the top. So A equals, and let's look at our scale. So 2 is actually up here, which means half of that would be right here, which means this is our 1. And half of that would be 0.5. That means our graph has a max of 0.5 and a min of negative 0.5. So A is equal to y max minus y min over 2. So 0.5 minus negative 0.5 over 2. That is going to be equal to 1 over 2, which is just 0.5, which makes sense. So our A is 0.5. Next, for our C value, or our axis of symmetry, it's going to be 0.5, so y max plus negative 0.5 y min over 2, which is going to be equal to 0. And then we look at our k value. So k is equal to 2 pi over p. Our p is equal to, so we look at our period. So we see that it starts at 0, it goes all along, around, and ends at 2 pi, back to the same spot. And or, you can also look at the peaks, like I said. So peak to peak, pi over 2 to 5 pi over 2, that's going to be 2 pi across. So our period is 2 pi. That means our k is going to be equal to 2 pi over 2 pi, which is just equal to 1. And this is actually looking like a pretty easy function to write the equation for. So to actually write the equation, so let's start with y equals, and let's first determine if we're going to use sine or cos. So by looking at this graph, I'm probably going to be using sine, because I could use cos. I definitely could use cos. That's an option if I included a shift, but I wouldn't really do that personally, because to me it looks like that the graph is starting kind of in between the max and the min, which is perfectly at 0, which is exactly how sine works actually, because your sine starts at 0, goes up to 1, then 0, negative 1, and 0, and then if you kept going backwards, it would go back down, and then up and down, it would keep going. And that's kind of the same thing that's happening with our sine graph, or sine cos graph, trig graph on the left. So because it looks like a sine graph to me, I'm just going to use sine. So we're going to do y equals sine. Let's just start that off. And then we have our amplitude, which is 0.5. So 0.5 sine. Now we see if there's a reflection over x-axis, and it doesn't look like it because it's simply going up. Now, if our graph were going down like this, and then like this, kind of doing this type of thing, if it had a minimum as its first kind of signature point, then okay, I would have a reflection. But because it doesn't, we have no reflection over the x-axis. So 0.5 sine, and then our k value is 1. So when k is 1, then that's just, instead of just doing 1x, or I should probably fix that. Instead of just doing 1x, that's just the same as x. And because we have no c value, there's nothing plus or minus anything. And there's also no phase shift, which means that is literally just our final answer, 0.5 sine x. Now, if you wanted to do a cos x version, what we could do is y equals, and let's put back 0.5 cos. So now if we want to do cos, we could do x. So if I'm just looking at it, we could do x. That would be x minus pi over 2, because the graph shifts to the right by pi over 2. That's definitely an option. Or another way you could even do it is do y equals negative 0.5 negative 0.5 cos of x plus pi over 2. Alright, this is going to be the final example for this video. So let's do what we've always done. So now we start with our amplitude. So the max is 2. The minimum, so y max minus y min. So the minimum is negative 4 over 2. 6 over 2 equal to 3. Done. Easy. Axis of symmetry is going to be 2 plus negative 4. Y max plus the y min over 2, which is going to be negative 2 over 2, which is going to be equal to negative 1. So that's axis of symmetry. K value, so you have your k is equal to 2 pi over p, period. I highlighted the two highest points, so that's you're able to find the cycle with, just because it's kind of hard to see on the graph. So 8 pi over 3 minus 2 pi over 3, that's going to be 5 pi over 3. And now if we plug that in, so k is equal to 2 pi over 5 pi over 3, then that's going to be equal to 2 pi divided by 5 pi, I'm sure you're writing it, 5 pi over 3. So 2 pi times, now you flip these around, so 3 over 5 pi. So that's going to be 6 pi over 5 pi, which is equal to, simply just equal to pi. Sorry, no, that is just equal to 1. Your k is just simply 1. Alright, so now that we have that, we can start our equation off. So we have y equals, and now again we figure out if we want to use our sine or cos. I am going to use cosine again, just because I can see that cos would normally start up here, and this is shifted 2 pi over 3 to the right. And because it starts at a maximum, we know base cos normally starts at the maximum. We know that there's going to be no reflection over the x-axis. So we're going to have y equals, and we can start with our amplitude, which is 3. So we have 3, then we can do cos. We check for our k value, it's 1, so we don't include that. So we just open brackets straight away. And we're going to have a shift of 2 pi over 3 to the right. So we're going to have x minus 2 pi over 3, because it's going to the right. And now we look for a axis of symmetry. So our axis of symmetry is negative 1. So then we have minus 1. And that is just going to be the answer for our graph. So, this equation now represents this graph. And you could maybe find it with sine. Probably if you did something like, what I would personally do is take away the phase shift. I would take this away. And I would also take away the negative 1 just for a little bit, because I'd want to bring the graph up to where the midpoint, it would be the midpoint of the sine graph. So let's say the graph right now looks like this. Just as an example, I would bring it up. So I would remove the -1, and I would bring it up until it is equal, because that is what a sine graph actually is. It's, the top half is equal to the bottom half, because that's like the axis of symmetry. So I would remove the -1, just assuming it was 0, and I would probably look for a phase shift, which would probably be about pi/6, but this is a much easier way to do it. Just look at the cos, or use cos, and then look for the positive, or sorry, look for the maximum or the minimum, and then just try to do a phase shift from there. That's probably the easiest way to do it. And that will conclude this second video. And in the next video, we're going to be doing the opposite. So we're going to be taking an equation and simply graphing it, which is probably a bit easier than this.